Here's a video going over a couple of the questions from your break packet in case you were stuck. So for the first section, factor and find the roots of each. I'm going to do my work on the page, but just to point out here in your directions, it says that all final answers should be written on a separate sheet of paper with appropriate work shown. So separate sheet of paper. Don't show me your work on here. I'm going to be collecting it. Now, factor and find the roots of each. So what we're doing here is add and multiply factoring. So find things that multiply to 4, let's see, so it's either 2 and 2 or 4 and 1. And then you need to make sure that they add to 5, so that's these two, 4 and 1. So that means that this is x plus 4 and x plus 1, and therefore my solutions are -4 and -1. And that's how you solve them all in this section. The next section, solve each equation by taking square roots. So what we want to do is we want to isolate this so that we can then square root it. So let's isolate it. -6 minus 6. That's going to get me 81x squared is equal to 49. Then let's get rid of the coefficient by dividing by 81. And now I've got that x squared is equal to 49 over 81. And I will square root both sides to get rid of the square. When I square root something to get rid of a square, I need to make sure that I take into account plus or minus. In this case, I could actually simplify this. Square root of 49 over square root of 81. Split it kind of like that. And then square root of 49 is 7. Square root of 81 is 9. So we're talking about plus or minus 7 over 9. So that's how you do every one in this section. Some of them will be simplifiable all the way, like this one was. Some of them won't simplify at all, so it's really up to you. You got to do what's best for that individual case. To simplify in here, if it's a square root, we're looking for perfect squares that divide into this. So let's think the perfect squares are 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49. In this case, I'm going to be using 49. This can be turned into 49 times 3. The n cubed can become n squared n. 49 is equal to 7 squared. And now I can bring out these two. The n and the 7 can give up their squares, and the bouncer will let them on through. So I get 7n, and the 3 and the n are left underneath. If it's a cube root, like number 25 is, right, cube root, you'd be looking for the cubes. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, etc. Those are the factors you'd be looking for there. If you have any trouble with that, there are earlier lessons and videos on those called simplifying higher roots or simplifying cube roots. And for the last section, this is the only section that should require a little bit of thought, a little bit of work, but we'll still make this quick. We've got an equal sign, so that means I can use my favorite trick, which is to make them all have the same denominator. So I'll multiply by 3 and 3. This is just a regular n, so I'll multiply by 3 and n, 3 and n. And now they're all 3n squared, 3n squared, 3n squared. Once they're all the same, we can cross them all out and rewrite it with just the numerator. So let's see what the numerator is here. I've got n minus 3, minus 3 times 1, which is just 3, is equal to 3 times 1 times n, so that's 3n. Now we combine some like terms. This is n minus 6 equals 3n. And I want to get the n's by themselves, so let me minus n to bring this one over. So I get -6 is equal to 3 minus 1 is 2n. And I'll divide both sides by 2 to get the n by itself. -3 over 2 is, sorry, -6 over 2 is -3. Now, we would of course want to make sure that when we plug this back in, it actually solves the original. I'm really only concerned about, in this case, the denominators, right? If it made any of these equal to 0, I would be worried about it. So if I plug -3 in here, nope, not going to make it 0. -3 in here, -3 squared is 9. -3, nope, so that's fine. If it made any of these denominator terms equal to 0, that would be a problem. And then we would cross it out. But that is not the case, so it is perfectly fine as a solution. Okay, that's all that this should really require. You're doing regular solution solving. This is a subset of Algebra 2 that we learned already called rational equations. So if you want a more elaborate look into it, or you need more of a video tutorial, that's what you're looking for in my YouTube channel. Okay, good luck. See you in class.